Hey everyone, welcome to IN-SPACe. Today I'm excited to introduce you my latest project, the Skyvoyager CanSat. This is the Skyvoyager CanSat, and it's basically a small satellite. Okay, it's a design for research and education purpose. Okay, and in this CanSat I'm using a lot of sensors, so I'll explain one by one. Alright guys, so this is my ground control software version 3. Okay, so in this software that I'm currently working on. Alright, so you can see this is my software. Okay, so this is the roll, pitch and yaw graph, and then it's accelerometer gyroscope graph, then it's a meter, roll, pitch and yaw meter, then uh, the threshold value and the warning message is plus minus 19 degree. Okay, so if CanSat is rotate around more than plus minus 19 degree, then it's so red value. So you can see, let us suppose the CanSat is a stable position set as 0 degree, right? So when you move the CanSat to 19 degrees, so it's a like the roll is the 90 degree, right? So you can see this is the roll, and the roll graph is 19 degree, right? So it's greater than 19 degree, so simply warning mass. And this is really interesting, man, right? So if the 19 degree, then it's turned on red, so it's a warning mass simply. Okay, and the second one is the magnetometer. So this is the magnetometer graph, and I just combine three XYZ in one single graph, right? And this is a compass. So let us suppose if you this is a CanSat, right? And if you move this CanSat, you can see this is a compass. It's a west, east, and the south and the north. So this is the south, this is the north, and this side is the south. Okay, and this is the east, so this side is the east and west. So actually I built this software last 1 month, and this is really challenging to build it because it's a lot of math and physics. Okay, and okay, so this is the local time, UTC time, and the Eastern Standard Time, right? And this is the run time, uptime, and this is the countdown. So the countdown is a start 1 hour before 1 hour launch it. Okay, so you can set the countdown according to your launch system, and it has in the second version, the second section is also has the abort section. So if any problem of your CanSat, you just abort the mission. Okay, this is the temperature, this is the BMP 280 temperature section. So it's a temperature, pressure, altitude. Okay, so this is the BMP 280, it's not a BMP 180. Now the second graph is temperature, pressure, altitude, it's BMP 180. Okay, so actually this CanSat I am using two BMP 280 sensor, BMP 180 and BMP 280 sensors. Okay, so it doesn't make any sense, but I just put it on two barometric sensors, 180 and 280. Okay, and this is the speed, this is the GPS speed basically. So it's a speed, and it's a state, that means how many satellites connected to your GPS. So currently there is no GPS, so it's so 0 0, right? So if GPS is connected, so it's simply so how many satellite connected, right? So it's basically new emit and GPS is connected around 8 satellite, right? And the second is the latitude and the longitude. So in the one graph, so the latitude value and the longitude value, right? And the GPS altitude. Okay, so these sections you can see BMP 280 section, BMP 180, and the GPS is the for latitude, longitude, GPS altitude, the state, and the speed. All right, and as you can see on here, this is a LDR value, right? So simply this is the time, and this is the X value. It's a simply raw telemetry data. Okay, so yeah, actually in this CanSat I'm using XB Pro H2Z module, so it's a long range and it's really good. All right, so this is my ground control software. If you like this GCS, like the video. Okay, and this is really challenging to build it. Okay, the second things is in this GCS, there is two options to save the file. The first is the CSV format, and the second is the JSON format. Okay, so first of all, if you start this is the two buttons, so it's a start CSV and the stop CSV. So if you click the start CSV button, so it's open the file, and where you want to save the data, right? So into desktop and download section, I just save this download section. Okay, so just open it. So in this time, all data save in CSV format. Okay, so let us suppose if this is a CanSat is moving around, it's moving, it's moving. Okay, And as you can see on the GUI, it's real time. Okay, so there is no lag, between the ground control software and between the serial monitor, between the serial monitor, right? So there is no lag. So cool, man, because there is no lag between the serial monitor and the ground control software, right? And the second part is, if you want to reset the graph, right? So if you want to reset the graph, simply this is the reset button. So each graph has the each reset button. So if you reset the button, then it's clear the graph, clear the previous graph, okay, and the start with the new one. Okay, so let us suppose I stop the CSV file and open the download section. All right, so wait, uh, 3. Okay, so this data. Okay, so as you can see, this is all data saved in CSV format. So it's a roll, pitch, yeah, acceleration, gyro, magnetometer, BMP 180, GPS, and this is the latitude, longitude, right? And this is the speed, satellite, right? So there is no satellite, and there is, right, so satellite value is not defined it here, and there's no latitude and longitude, so that's good. And as you can see, there's a bunch of data, like 1300 data in just 1 minute, right? So that's cool, because the delay between the delay is around 10 millisecond, right? So each 10 millisecond save one iteration of your data, right? So that's cool. Okay, so back to my GCS. So this is a GCS. Okay, and there is another is JSON format, so you can save all the value in the JSON as well as and a stop JSON file. So if you like this video, you can comment it, and if you really like this GCS and you like the CanSat, please comment it below. Okay, and I will see you in the next project. Bye bye.